We celebrated this year 20 years of the discovery of graphene, and I was one of the first scientists to look at this material from the theoretical point of view. Two friends of mine got the Nobel Prize for that, and I was recruited by Singapore to go there and start a research center. And I've been there for now 15 years.
Welcome. First of all, let's start with a quick introduction. Can you tell the audience a bit about yourself?
Hello, hi. My name is Antonio Castro Neto. I'm director of the Center for Advanced 2D Materials and the Institute for Intelligent Functional Materials at the National University of Singapore.
Materials for 15 years. Looking at the future, what excites you the most about graphene and such materials, or what applications are you excited most about?
I think that there are several aspects. Graphene now, from the scientific point of view, it's a very developed area of research, although from time to time we have some huge surprises. But now graphene is really a topic for the industry. So at the center that I direct, we have been now exploring applications of graphene in several different areas, like composite materials, electronic, thermal managed sensors, and so on. So there are many possible applications, and there is a lot of demand from the industry. And graphene is such an extraordinary material that can solve many different problems. So this is, say, the more applied thing, a part of it. But there are many other two-dimensional materials besides graphene, and we are studying those as well. So recently, I can give you an example. We developed a new type of green concrete using a two-dimensional material, which is an aluminum silicate.
Okay.
So this new concrete, unlike the ordinary concrete, the Portland concrete, it doesn't produce any carbon dioxide.
Oh, okay.
So it's completely green. And not only that, it's a very versatile type of concrete, and we can use to make concrete, you have to put sand, right? In normal concrete, you have to use sand from rivers. You cannot use sand from the desert. And with our concrete, you can actually do that.
Okay. I mean,
So actually, one of the reasons why 2 weeks ago I was visiting several countries here in the Arabian Peninsula was exactly because of that. Because you have, besides a lot of oil, you also have a lot of sand. So I think there is an opportunity for the countries in this area to use this kind of green concrete. So many things. Again, I think that the key for all this is that these materials are extremely thin, and they are very easy to modify chemically. And because of that, they can be used in many different applications.
Yeah, definitely. So a question about, like, now you've been working a lot on materials and stuff. So how are you able to continuously kind of innovate and find new kind of, as a scientist, how are you able to continuously innovate and find new 2D materials that would be used in many different applications?
Look, my perspective is very simple. The world is a place with many challenges, right? So we have the climate crisis. Just look at what happened recently in Spain with the flash floods. What happened here in Dubai as well, right? So chain, energy, water, which is also a very important topic in this area. So for me, it's actually identifying the target and trying to find the solution for that problem. And I have a material which is extremely flexible from the point of view of applications. So the question I ask myself is that, how can I use these materials to solve these challenges?
Of course, So you're kind of developing the materials and then looking at the different challenges you're facing and how you could add this new material to kind of fit this challenge you're trying.
Exactly. So that's the idea. And of course, for that, you need resources, you need investment, and so on. But I have to say that Singapore is a very generous country for research and technology. So we have been doing very well.
The field you're working in is very interesting to many people. So what advice would you give people that want to enter the field of 2D materials and want to develop things with a purpose? Like, what would you tell them? Would they start with in a specific area, like read books, or would they need to go to university and then get a master's? Like, what would be the roadmap for them to enter such a field?
I think that science became a very interdisciplinary activity. In the past, you have these like pure fields, right? Physics, chemistry, biology, and so on. It's not anymore.
Of course. Yeah.
Because the challenges of the world today involve everything.
Yeah.
Think of the climate, for instance. It's
a lot of things. Yeah.
It involves all this, right? So I think that when people pursue an education, I think they have to think broadly.
Okay.
And not necessarily become a super expert on something, but have a broad vision of the world and understand the basic concepts and the basic elements to solve problems.
Yeah.
I think we need more and more problem solvers.
Yeah.
And also something which is definitely very important nowadays is that people educate themselves about artificial intelligence, machine learning, because we are now in a journey which I believe we passed the point of no return. And these things are going to become more and more important with time. So I think it's very important that people learn about these things, demystify themselves about this, because there is a lot of hype, things like this. But in the future, I think this is going to be part of everybody's life.
Yeah. So basically, with all of those technologies, they need to look at the actual application in their field. And honestly, this has been a great interview with you, to be honest. And thank you so much for the advice you've given everyone. And thank you so much for the contribution you're doing to the world.
Thank you very much. Thank you for having me here.
Of course. Thank you so much.
Thank you.
Thank you.